Hello everyone, welcome back to another video with Mr. Coder, and in today's video I'm going to show you how to solve attribute checks question D from Educational Codeforces Round 170, rated for Division 2. So imagine a game where you play as a character that has two attributes, strength and intelligence, that are both at 0 level initially. And during the game you'll acquire M attribute points that will allow you to increase your attribute levels. 1 point will increase one of the attributes by 1 level, but sometimes you encounter a so-called attributes checks. If your corresponding attribute is high enough, you'll pass it, otherwise you'll fail it. And spending some time, you finally prepared a list which contained records of all points you got and all checks you've met. And now you're wondering, what is the maximum number of attribute checks you can pass in a single run if you spend points wisely? And note that you can't change the order of records or whatever. So the order you're given is the order you have to do it in. So you have N and M. M is less than or equal to 5,000, and it's less than N, and N is less than or equal to 2 times 10 to the 6th. And that's the number of records in the list and the total number of points you'll get during that game. And the second one contains N integers that are R, which contains the ith record. So if Ri equals 0, that's you acquired an attribute point that you need to put it on either strength or intelligence. If Rvi is greater than 0, then it's an intelligence check. So you need to check if the intelligence level is greater than or equal to Ri, which then you pass, otherwise you fail. And then if R is less than or equal to 0, it's a strength check. So you need to check if your strength level is greater than or equal to the absolute value of Rvi. And if so, you pass. And then all it contains exactly M elements equal to 0, which means it's exactly M check. Or M amount of attribute points that you'll get. And so we'll go through the first example. So you can put this, there's multiple different ways you can approach this. So first you can you can just put this on intelligence, you can get past this check. Put this on intelligence, you can pass this check. And then there's no more intelligence, so you decide to put strength, so strength, strength, strength. But then you can't get any of these strengths. Like for example, you can't get this 3 because at the time you passed this, you only had a strength of 1. So that answer would only be 2. But if you instead put this as strength, 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 then you would pass this strength, these 3 strengths. So that's why the answer of that one will be 3. For this one, your coin that you got, or your attribute point, is after all the checks, so you cannot pass any of them by default because they start at 0. So a key thing to notice on this is when the constraints on the variable seem suspicious. So for example, like N is less than or equal to 2 times 10 to the 6th, but M is less than or equal to 5,000. So that hints that it might be somehow related to M squared, because 5,000 times 5,000 is 25 times 10 to the 6th, so that fits in time. And it definitely seems strange how it's also less than N, which is less than or equal to 2 times 10 to the 6th. So that hints that you want to do M squared. And after a little bit of thinking, you realize that this is like a DP problem. So it's like a 2D DP problem. So the first one is, so for going down, it's how many points so like the acquiring attribute points, like these like zeros or whatever, like which one you're on. So like this one would be 1, this one would be 2, 3, 4, 5. So it'd be like that. So that's M plus 1. And then this next one will be how many you spent on intelligence points. And note that you can calculate how many you spend on strength points by just doing the current amount of the points you've gotten already, which is this first one, minus the amount you spent on intelligence points. And then this is a DP plus a data structure, which I use ordered multiset. And if you don't know like how to really use ordered multiset, it's up here in my template. So use this, and then this thing is compared to the normal ordered set, this ordered set is less, and then these parentheses, and but this is less equal to. So the only difference besides it containing multiple values is that you have to make sure that when you erase, you can't just erase a certain value, or you can't do erase something dot find. You have to use dot upper bound that value, and that'll end up working since the less equal to swaps the upper bound, lower bound, and whatever. So that's why you have to do that. So I have an ordered set of the intelligence and the strength, and I set the current amount like past like what I explained here, the number of zeros to be 0 to start, and then I go through each of the n points in the array, these which includes the checks and the points acquiring. So first, if it's greater than 0, which means that it's an intelligence check, then I'll just erase it uh from the ordered set. And if it's a strength one, I'll erase that strength one from the ordered set. So then like I can't accidentally get it later. And notice that I'm not updating it for the DP array here, because if I erased it here, then it would be a O of NM time complexity, which is too slow. So that's the key thing, optimizing O of NM into M squared, N plus M squared. So if it's equal to 0, then you add 1 to the current. So this is how many attribute points you have. And then you can go through until the next attribute point and insert them to the ordered set. This is when you insert them. You insert them into the ordered set. And erasing it here like this prevents overcounting, and inserting it like this. So, and then you go through all possible amounts of intelligence points that you have. And then for the DP of the current amount that you're at, and then J, which is the amount of intelligence points you put on it, is equal to the order of key. So the number of checks less than or equal to J. So you just do J plus 1. And the strength less than or equal to current minus J, which is current minus J plus 1. So you can just add them up and put that into the DP. And the reason why this isn't O of NM, even though you're looping through, I'll explain each for loop. So this one, it's not O of NM because you'll only go through, this will only go through a total of N things because you're only doing this at every 0, and 0 you're going through them. And then this next one, this goes through M, but this only happens M times because there's only M values equal to 0 according to this. Contain exactly M elements equal to 0. So this is why it'll be M squared. So then the DP transition now that you have the however many DP at that current spot, now you can use transition states. So you can loop through the amount of checks and then the amount of intelligence points you use on it. You store the old DP, and then if J is greater than 0, then you can compare dp of ij with dp of I minus 1, j minus 1 plus the current one. And that'll work, and that's adding an intelligence point. And then if j is less than I, then you could do compare it to dp of I minus 1 and j, which is adding 1 to strength. And then you add the old dp. And then at the end, you just find the maximum element of the DP row of the DP, like of the after the M checkpoints, or after the M times we get acquire points. So that's how you solve uh attribute checks. And I know there's many different solutions. Most of them contain DP, and then there's some ways that include like prefix sums or like a segment tree maybe, but yeah, so that's how you solve attribute checks. Question D from Educational Codeforces Round 170, rated for Division 2. So yeah, thank you for watching this video. If you like this video, please like and subscribe, and I'll see you in the next one. Bye.